Well, hello, pre-calculus students and seekers of truth. In this video, we are going to conclude our lesson here on sinusoids by one example that's a little bit backwards. We want to write a sinusoid with certain characteristics. And let's remind ourselves, a sinusoid is a function that can be written in this following form. A times the sine of bx, this is the b right here, plus c plus d. Okay. And remember some of the important features here, that a, or rather the absolute value of a, is the amplitude of the function. That's the highest point minus the lowest point divided by 2. B here affects the period. So remember that the period, which is normally 2 pi, right? But this b multiplier here changes the period to 2 pi divided by b. The D here is the vertical shift. It could go up or down. And the C here is the horizontal shift. But for this problem, I'm going to use a slightly different modification of this version, where we have sine of parentheses B quantity x plus, I'll use H here, plus D. So I'll use a modified version of what we had before. Everything else is the same except this H here. This is going to be our phase shift. Okay, this is how much we shift after the function has been horizontally stretched or shrunk. And as we go through this example, you'll actually see why the phase shift is so much easier to use than the horizontal shift. So let's get right to it. Now I'm going to draw a bunch of sine graphs here, just so that it helps you to visualize what's going on. So the original sine graph is going to look like this, right? It's going to go through 0, 0, and many other points, but we know that it at least goes through 0, 0. It has a max of 1 and a min of -1, and then it's going to go here. This is pi over 2, pi, 3 pi over 2, and then 2 pi. Bring this up here, this should say 2 pi. Okay. But if we want an amplitude of 5, then let's just multiply everything by 5 in the front. So we get 5 of x, 5 sine of x, right? And the period here, let me clean this up here. We know that the period is going to be 2 pi over b, and we want a period of 8, right? So the period is going to be 8, whoops. So the period here is going to be 8, and that's going to be equal to 2 pi over b. So if we solve for b, we know that b is going to be 2 pi, b is going to be 2 pi over 8, or otherwise pi over 4. So we know that we're going to have pi over 4 times quantity x. And if you graph this, right, we get a slightly a sinusoid that's closer to what we want. We're going to start out at 0, we're going to go up, and we're going to go down, and we're going to go up, right? And then over here, same thing, right? But instead of going up to 1, we're going to go up to +5 and go down to -5. And instead of having a period of 2 pi, this is our new period is going to be 8. So that means when we make a full cycle from here up and down and back up to here, this point here will be precisely 8. And this point here will be halfway of that, so that's going to be 4. Right? So remember that the period is 2 pi over b. Therefore, if we set the period equal to 8 and we solve for b, we get pi over 4. So this function right here is this graph. And if you notice, it has a period of 5, so that's done. I'm sorry, an amplitude of 5. It has a period of 8, and that's done. So now all that's left for us to do is to shift the function. We want to shift it so that it goes through the point 2, 3. Now, so I like to pick any point here to be my reference, and you can pick any point, but it's nice to pick the origin. So we're going to say, how do we change 0, 0 to 2, 3, right? So if you want to go from 0, 0 to 2, 3, what we're doing here is we're effectively going 2 to the right, right? 2 to the right, and then 3 up. So we're going 2 to the right, and then 3 up. Okay. So that's going to change our graph a little bit here. So instead of 5 sine of pi over 4 times x, what we end up with is 5. Oh, that was huge. Let's try this again. What we end up with is 5 sine. Make it clear that this is a number 5. That did not make it clear. Let's try it again. This is 5 sine, okay, pi over 4. And we are going to have to move it up 3 units, right? So we're going to have it a plus 3 at the end here. And here's what the great thing is with the phase shift. We've already done all of our stretching. And the phase shift allows us to do the shifting after the stretching. So then instead of doing just pi over 4 times x, we can do pi over 4 times quantity x minus 2. So this will shift everything over 2 units and up 3 units. And our final graph is going to look like this. We are going to have the xy axis still, but we're going to start out here at 2 and 3. And this is going to be our midpoint. This is going to go where it used to pass through the origin, it's going to pass through 2, 3. And it's going to have an amplitude of 5. That means that when it goes up, it's going to go from 3 all the way up to 8. And then it's going to come back down, all right? And then it's going to come all the way back down to -2 down here. So let's see how I got that. The minimum used to be at -3. The maximum, it's at -5. The minimum used to be at -5. The maximum used to be at +5. If we shift everything up 3, then the max is 8 and the minimum is -2. And then the wave will look like so. And again, not a perfect drawing here, but you can verify this on a calculator that this takes care of all the requirements. It has an amplitude of 5, it has a period of 8, and it goes through the point 2, 3. And the phase shift here makes things a lot easier because we can basically do all of our stretching and shrinking first, and then just move the origin to the point 0, 0 to the point that we're looking for. Okay. So these are examples that are somewhat abstract, but I promise we will apply what we learned here to some very specific and practical examples. What's key right now is that you understand the features of a sinusoid and how do we incorporate transformations along with those. As always, thank you so much for watching. Ask questions if you have them, and have a wonderful